How do students learn science? Students first must explore what science actually is, and they will see for themselves that science is not just a collection of facts. It's not merely a set of laws governing nature. Science is the process of thinking that seeks to research a phenomenon or solve a problem. Science is a cognitive skill composed of many different skills, which together form the scientific inquiry process. These inquiry skills should be taught explicitly and often. After an engaging intro lesson, students can formulate the essential questions, explore these questions, explain observations, elaborate on their learning, and practice self and peer evaluation of their products. This places the student at the center of the classroom, where their active interaction with the content ensures a greater understanding. Inquiry demands a lot of students cognitively, but provides ample opportunities to practice process skills so valuable to their future professional success. I emphasize process skills by including procedural objectives in the lesson objective run-through. So students know what particular process skills would be the focus of the lesson and how these processes will help them understand the higher objectives. For example, the overall higher objective might be to plan and execute a synthesis reaction to provide a green alternative to lead paints, with the final product able to be expressed in multiple ways to individualize the assessment. The chemistry content objective on this first day might be to identify and compare types of reactions, which is important chemically, but fairly dry and in most cases is unlikely to be an enduring educational outcome for students who do not go into STEM fields. The procedural objective, on the other hand, is likely to be broadly applicable across disciplines and will yield an enduring educational outcome. In this case, to observe a system for important details and infer meaning, essential skills. The language objective similarly, in this case to provide oral and written feedback on a peer's product, is also broadly applicable across disciplines and is likely to be an enduring educational outcome. The best approach for planning an inquiry-based learning cycle is to start from the end and work backwards. What is the overall goal of the cycle? How can a product be designed that evaluates this goal? How can this product be designed that it's engaging and meets the needs of all learners? Once the end has been visualized, the nature of the product should give some ideas as to the individual lesson goals. It can be overwhelming to think about all the options when it comes to planning a lesson sequence. So you got to use the resources you have, which most importantly are people, your colleagues who provide a wealth of shared experiences to improve instructional strategies. There are other resources in the children and families whose experiences may greatly inform planning, taking into account socioeconomic and cultural differences. To best foster learning with my students, I must exemplify these processes myself, adjusting my practices by working with all invested parties, because we all share the same common goal, enduring positive educational outcomes for our students.